Welcome. Today we are walking through the application flow of FloodGuard-AI, an AI-powered urban flood prediction and early warning system submitted by Team ArcAlgo. You can follow along by visiting the deployed app at Versal. Urban flooding is a major challenge driven by heavy rainfall and poor drainage. Traditional meteorological alerts fall short because they rely on manual batch processing and static thresholds, offering reactive warnings that only give citizens hours to prepare. FloodGuard-AI solves this by utilizing Google's Gemini AI and a scalable MERN stack to forecast floods before ground impact. Let's explore the step-by-step flow of how this data becomes a life-saving alert. The flow begins with live data ingestion. Instead of relying entirely on expensive physical sensor infrastructure, the application acts as a smart aggregator. The Node.js backend pulls real-time environmental data via external weather APIs like OpenWeather and the IMD. It synthesizes this live weather data with historical geological datasets and soil moisture readings. This continuous stream of environmental data is fed directly into the system's cloud-native architecture hosted on the Google Cloud platform. Once the data is ingested, we move to the core of the app: predictive analysis and AI processing. The backend forwards the preprocessed data to a dedicated Python machine learning service. Here, models like LSTM and regression are trained to generate baseline predictions. Simultaneously, the data is processed by the Google Gemini Pro API, acting as the system's cognitive engine. Gemini actively monitors for multivariable anomalies in the raw meteorological data. Because it uses context-aware LLMs and real-time streaming AI, the system can proactively detect flood risks days in advance, placing users in a proactive zone rather than a reaction zone. Step 3 is where the system translates data into action through contextual alerts. The app uses a strict internal logic. If rainfall exceeds a specific threshold and heavy rain is forecasted, the system flags the risk as high. Moderate rainfall flags as medium, and otherwise, it's low. But FloodGuard-AI goes beyond generic SMS warnings. Driven by Gemini AI, the system evaluates the user's specific geolocation to generate hyperlocal, multilingual evacuation instructions dynamically. Citizens receive customized safe route instructions tailored to their distinct neighborhood via high-contrast mobile alerts and SMS. Finally, in Step 4, this intelligence is routed to the React.js front-end dashboard. The system provides a frictionless interface for two main groups: citizens and emergency responders. While citizens are navigating safely, authorities get real-time updates on a live, interactive map powered by tools like Leaflet.js or Mapbox.gl. The dashboard provides resource mapping, rendering live GIS data and identifying high-risk zones so responders know exactly where to deploy help. The map even allows for user-reported flood updates, essentially crowdsourcing ground-level data. To sum it up, FloodGuard-AI takes raw environmental data, processes it through advanced machine learning and Gemini AI, and outputs dynamic, localized safe routes to both citizens and authorities. With its highly optimized JavaScript architecture, the platform maintains low costs while remaining infinitely scalable. Thank you for watching, and be sure to check out the live prototype to see predictive intelligence in action.